Hello everyone, welcome back to another session by K21Academy. Today our experts trainer will be discussing about Delta Lake architecture. So let's get into the video.
So let us discuss the Delta Lake architecture, right? Delta Lake architecture. And now you will ask a question that, hey, we have studied a thing called as a data lake, right? That is called as your ADLS Gen2, Azure Data Lake Storage Gen2, right? Then we also know that this provides us something called as a true HNS, true hierarchical namespace. And HNS is just a fancy name for a file system, root file system, the subdirectories, directories, subdirectories, folders, subfolders, and so on and so forth. That's what your hierarchical namespace is. And it also provides us something called as ACL, access control lists, right? You know that. Then what is this Delta Lake, right? What is this Delta Lake? So the Delta Lake is a solution for some of the issues that are encountered on a raw ADLS storage layer. So when you have a data lake in which you keep all your data, the protocols of the operations, which means reads, writes, updates that we do on the data lakes, do not support ACID properties, right? ACID properties, which you have studied in the DP900 ACID, right? Atomicity, consistency, isolation, and durability. So if we are aware about the relational databases, we know that when we execute transactions in relational databases, in order to avoid dirty reads, we must execute the transactions in a linearly serializable way. That is called as atomicity, consistency, isolation, and durability, right? Isolation, and then durability of the transactions. So the meaning is that if you have concurrent readers and the writers and updaters, that is, they are doing delta changes onto the data lake. Data lake does not provide you the guarantees that the write and the updates will be atomic. They may fail in between, right? And there is no way to revert back. We know that in the databases, RDBMS products, relational database management systems, you take SQL Server or you take, let us say, Oracle or any other relational RDBMS product, we all know that an RDBMS system has something which is called as a transaction log file, right? Transaction logs. And why do they use transaction logs? Transaction logs essentially keep a log of active transactions which have not been yet committed or rollbacked, right, into the system. And using the transaction log, we can do recovery and restore procedures in case of data movements. We can do redo and undo, right? Undo and redo logs using these transaction logs. In essence, if something goes wrong, some fault happens, transaction log is used for fault tolerance. We will be able to recover the state of the database, restore the state of the database by using the full backup, the differential backup, and the transaction log backups by applying them in the full recovery mode. So transaction log helps in the RDBMS products to undo and redo something which is not possible in the lake. Lake does not have a concept of a transaction log. It does not maintain a transaction log, right? So if you have readers and the writers and the people who update the data lake, it has no guarantees that your writes and the updates will be atomic, as a result of which you are in a state of a potential corruption, right? There is a potential threat to your entire consistency of the lake. Your lake may not be reliable, right? If the data goes corrupt, the data lake goes unreliable. And when you have an unreliable data lake, you cannot develop your recommendation systems, artificial intelligence solutions, your synapse, that is your decision support systems, and so on and so forth. Everything goes in hang because you don't have reliable data system for you. So Delta Lake is a storage format implemented on top of existing storage layers like Amazon S3, Azure Data Lake Storage Generation 2. It's an engine that helps us implement certain properties that are desirable in the modern context of processing. It primarily helps the Delta Lake engine, which was invented by Databricks, right? So this engine, Delta Lake engine, was invented by Databricks, and it is basically a data storage format that is implemented on top of an existing storage layer like HDFS or ADLS Gen2 or Amazon S3 and so on and so forth. It is open source by May 2019. It is open source by Databricks, and it is most primarily important for atomic operations, something that makes us ACID compliant, something that makes us fault tolerant. And how does it do? It maintains a transaction log called as a delta log of all the commits, that is the writes and the updates that we are performing on the underlying data. So whatever the underlying data may be, if you perform writes and updates on those data, the Delta Lake engine in the Delta format will maintain a Delta log file, which will keep essential information for you to undo any kind of a change that you think has corrupted the state of your data. So we will be able to recover the state of the data in case something goes wrong. It has other features as well, some advanced features, time traveling, Z ordering, and so on and so forth, right? I have an advanced notebook for our participants in which you will be able to look at each and every feature that is of relevance to us in a hands-on approach in that notebook. But as of now, this much information is sufficient for us to proceed that the Delta Lake engine provides us a storage format that helps us make lakes ACID compliant, fault tolerant, right? And it is used, the word delta signifies incremental data sets, incremental processings, changes, right? When they happen, which happen in real-time processing most frequently. You get your data in increments, delta increments, right? But that does not mean it can only be used for real time. It can also be used for streaming. It can be used for batch as well. But the word delta signifies that it has the most important use cases when the data sets are incrementally arriving, right? Which is nothing but a real-time stream. That is your incrementally arriving data set. Now, what is Delta Lake architecture? Delta Lake architecture is a reference architecture that data engineers recommend people to use, right? So it's a reference architecture that you as a data engineer should implement. It's a reference architecture. The choice of technology can be anything, right? So it's a reference architecture which you can use. So we're going to be implementing it with Spark structured streaming. So in the Apache Spark APIs, right, we have the Spark structured streaming API. Our aim at this moment is not to study the structured streaming API. We have a dedicated module number 11 on it, in which we shall discuss what is the structured streaming API. All right. But the choice of our current discussion would be, as far as implementing this reference architecture would be, technology design decision would be that we would be using Apache Spark structured streaming API along with Delta engine, right? So we will be using the Delta Lake engine, right? All right. And we shall be unifying, the aim would be to unify streaming plus batch, right? So we will unify streaming plus batch. So the scenario is something like this. What I want to say is this is the scenario. With the scenario in the perspective, it would be easier for us to understand that what do we really want to implement. So the scenario is unify structured streaming, and batch jobs with Delta Lakes. And the technology choice, I have already highlighted to you that what is the technology choice that we will be using. And we will be unifying streaming and batch together along with the Delta Lakes, right? So now let us discuss the architecture. How will we do that? So right now, we will be using streaming data. Now, we do not have a source of streaming data at this moment, right? We don't have an application or an IoT device that generates that real-time streaming data. So we will simulation of the data, right? So what we have is a lake, right? So we have a lake, a data lake, okay? So we have a lake, right? So we have an ADLS Gen2, a data lake, and in the data lake, we have 36 JSON files. We have 36 JSON files. Each file has 5,000 records, okay? 5,000 documents, you can say. A single file has 5,000 documents. We will use this data as a simulation of real-time stream. So what we shall do is that we will read this data that you have. Let me show it by this box here. So we will read this data as a stream, right? So we will read stream. So I will write read stream. So we will read this data as a stream, read stream. Format of the files is JSON, as you can clearly observe. And we will supply an option. We will say that, hey, I want to read one file every second, right? So one file, 36 JSON file, one file every second. So it becomes a stream of file that is arriving to you. You can say every second you are getting 5,000 records. Every second, the input rate is 5,000 records per second. So I want to read one file every second. Now, because this is a file and it is a stream, we need to tell the schema of this data, that is the name of the columns and the data types at the query time. That is when we are writing the program, because it's not possible to infer the schema from these files without scanning them, right? And because the stream starts from nil, it's not a batch, right? So it's a stream, one file will come every second. So we need, as a developer, to supply the schema, right? So we will also supply the schema properly. that what is the schema of the data. Schema we mean name of the column and the data types that these JSON files contain, so that the stream is able to be parsed. Okay, and why do we need to supply the schema? The reason being that a stream starts from nothing. A stream starts from 0 records. It's not a batch, so we are not able to scan them as a part of the stream, right? We cannot scan these records when they arrive as a part of the stream. So we will have to provide the schema. All right. So we will read the stream from here. We'll say one file at a time. So it becomes a stream of files like this. And the format is JSON. We'll read them. Now comes the most important part. From here starts the recommendations of Delta Lake architecture. What does Delta Lake architecture tell us? What it tells us starts from here. It says when you get a real-time stream, something like this, whatever the data is arriving to you, the data must be made fault tolerant. You must copy this data into Delta Lake as it is a raw copy, right? So we're gonna be writing it, write the stream, right? So we're gonna say as it is, right? That is called as a raw copy, as it is. That is a raw copy. A mirror copy, we will, whatever the data that is coming, incoming stream, we're gonna write it, write the stream, right? So we'll say write a stream here, write a stream. Write the stream at some folder location. So here we will have a folder location, right? In this folder, we're gonna write the data files. Now, why are you writing here? This data that is arriving is in a JSON format, which is not fault tolerant. It has no guarantees of all that, transaction logs and all that. So you need to convert JSON into Delta format, right? So when we're going to write this, we shall say that I want to write this in the Delta format, dot format Delta. So we're going to say, hey, this is JSON and this is not fault tolerant, but I want fault tolerance, ACID compliances. I want a transaction log. So I will say dot format Delta while writing in certain folder. So an incoming stream, which we are reading from here, shall be written as it is, just a mirror copy, but the change is in the format. We will change its format now first, dot format Delta, and write it in a folder. This folder has a fancy name, right? People call it as a bronze table. Let me use a brown color just to make sure that it's looking like a bronze. I will have to look at the entire color chart. Okay, let's use red only. Bronze. People call this folder with a fancy name called as bronze. Raw Delta copy of your data. Raw Delta copy of your data, right? Nothing, as it is, whatever you are getting, you copied it, but you changed its format. Okay, all right. So you were getting a stream, you were reading a stream from some source. In our case, the source is ADLS Gen2 JSON files. You give some configuration options, then you write as it is into certain folder, you change the format and you call that folder by a fancy name called as bronze. Okay, now what do you do? Now what does Delta say? Delta Lake engine say? Delta Lake architecture, the reference architecture say? So the reference architecture says you this, that once you have copied it into a bronze folder and now the format is Delta, right? It will maintain a transaction log. I will show you the files, don't take any issue. Now, what does it recommend? It recommends to transform this, join it with other sources, do stream joins, stream static joins. So this is a stream, you could join it with other streams. You could join it with some static sources, that is called as static data frames, not streaming. When we will implement, it will become more clear. Format change simply means it was in originally JSON and now it will become Delta, right? That's the meaning of it. When we will implement, it shall be more clear. Right now, the concept might be a little bit on the higher side on the. So now, what does it say? Delta Lake architecture. The Delta Lake architecture says, go ahead and please transform it, right? So what we're going to do is we will read a static data frame. So we're going to read a static data frame. So we will have a file on the lake. So here is a lake again, right? You have the lake, that is ADLS Gen2. You have some file here, which is in Parquet format, column oriented Parquet format. So we're going to author a data frame on it, which is a static in nature. We're not going to stream it. We're going to say we want to just read it as a batch, read it as a batch. So this is called as a static source, static thing. It is not incremental, it is not a stream, it is a static. We load it, and what do we do with it? We join it with this stream. So this is a stream which we have to now read from the bronze folder. So we will say read the stream from the bronze folder, which has been written to the bronze folder. So read the stream from the bronze folder, and which format is in, it's in Delta format. So we have to tell it that the data that I want to read, it is in the Delta format. Earlier we said it is in JSON format, and now I say that I want to read it, and the data that I want to read is in Delta format. Okay, read the stream dot format Delta. I will read it from here. I will read something from here, which is Parquet file, right? Parquet, block oriented, column oriented Parquet files used for big data analytics, provides us compressions and other benefits. What do we do by reading this? So this is a static, this is a stream. This is called as a stream static join, right? So we shall do something which is called as a stream static join, right? So this is called as stream static join, stream static join. You can do stream join, stream static join, static join, right? We are not going to do that much of detail, but just for an example, we will do what's called as a stream static join. Then we shall do some transformations on this, whatever the joined is, the data that we joined, we're going to do some transformations on it, right? So some transformations, I will say it by a function f to signify transformation functions, right? Whole classes of transformation functions. We will perform some transformations. Okay, transformations like pivoting, cleansing, converting data types, removing null columns, imputations, putting mean, median, all those transformations that you can do. Then after you have done all your transformations, you did joining transformations, advanced transformations, minority samplings, imputations, right? data balancing. Once you did everything, whatever you wanted to do as a part of your transformations, basic and advanced transformations, your data is ready for query purpose. So your data is now ready for query purpose. So what does the reference architecture say? Delta Lake reference architecture say? The Delta Lake reference architecture then says, please write your data, whatever you have after these transformations, as a stream. Write it as a stream. Write it as a stream. Again, in a fault tolerant delta format, dot format delta. So write it as a stream with dot format delta in a folder. Right? So there will be one folder in which you shall write. And people call that folder by a fancy name called as Silve. Right? People call it by a fancy name called as a Silve. This is called a Silve or query table. Silve or query delta tables. Query slash Silve delta table. Don't confuse yourself with the word table. Table is to signify that it is ACID compliant now. This is called as a bronze table or raw table, right? These are folders, right? These are just folders. People call them by fancy names, Silve tables, query tables, like that. Now, why is it called query table? Because it is ready for your aggregations. Now you can report your business aggregates in real time because it is all stream that is flowing. It is all stream that is flowing. So you can now report on your business aggregations. And now to report on your business aggregations, you have two mode of operations from the Silve table. Yes, you have two modes of operations from the Silve table. Delta Lake reference architecture gives you freedom to do two things. The first thing is what people generally do. What is that? So they say that you author something called as a real-time view by reading the stream from here. So you say read the stream from Silve folder. Read the stream from the Silve folder. Silve is obviously in the delta format, so dot format delta. Dot format delta. You read it from here and author what? Author a real-time view, right? Author please a real-time view. Real-time view. We shall see all that in the hands-on lab. Author a real-time view. And once you have authored the real-time view, you can develop real-time dashboards and visualizations and reports. Real-time dashboards. Real-time dashboards. Visualizations. Visualizations. Reports, whatever, using your queries, aggregation queries. Right? So you can write these aggregation queries and you shall be able to develop real-time charts and dashboards. That's what we want in reality for business intelligence and all of that. Real-time charting, real-time dashboarding. As the data flows in, your report changes in real time. Your visualizations automatically refresh in real time. All right. Then second option is what? Second option is a static method. It's not a real-time dashboarding, real-time visualizations, a static method. It says you read the stream from here, Silve, read the stream from the Silve in the format which is obviously Delta. You have written the Silve table or the Silve folder in the Delta format. Then do what after reading? Do all your aggregations, right? Whatever your group by clauses are there, aggregation, by aggregation we mean group by and all those things. Sum, average, min, max, right? So you do your aggregations by reading this and write it where? Write it in a separate folder. Write it in a separate folder. So read, do group by, window-based analysis could also be done. You can say group by, but every 1 hour data. Windows can also be created and all your aggregation functions can be used, sum, min, max, and all of that. You write the stream in the format Delta, but where do you write it? You write it in a folder, and people call that folder by a fancy name called as gold, right? People call it by a fancy name called as gold table or gold folder to signify business significance for it. It has business meaning to the company because it contains business aggregates. It contains business aggregates which needs to be reported. But once business aggregates are sitting here, you can query them statically. So you can query them statically. Query them statically. SQL dedicated pool does not come here. This is Spark. We are talking about Spark. Dedicated pool, no. Folder will be in the data lake, Delta Lake, right? Dedicated pool is a data warehouse technology. We are talking about Delta Lake engines, which are on top of data lakes. And the choice of technology that we have selected at the top is Databricks or Apache Spark Structured Streaming API, right? So we will be able to do static query, right? We'll be able to do static queries on this. And this is what is called as the reference architecture of Delta Lake architecture. This is what people call reference architecture. Delta Lake architecture, bronze, silver, gold, refinement. Refining the raw streams, fault tolerant manner. The stream is successively getting refined till the gold level, that too in a fault tolerant way. If something goes wrong, because I am maintaining these folders in the Delta format, I will be able to recover any fault. I will be able to recover from any fault because for every folder that I have, along with that folder, I will also keep another folder for checkpoint data. That is called as a checkpoint folder. So I will have a bronze checkpoint folder. I will have a silver checkpoint folder. Silver checkpoint folder. And I will also have the gold checkpoint folder. Right? So I will also have gold checkpoint folder. These checkpoint folders will keep information that would be required in order for us to recover from any fault when it occurs in this pipeline. Right? So this is the reference architecture, which is called as Delta Lake architecture. Things will become more clear when we implement it, right? Yes, you can. You are right. But in Synapse Spark tools, Synapse Spark Pools. Synapse is a very vast technology. Synapse Spark Pools. We can implement the Delta Lake architecture in a Synapse Spark Pool, as Jonathan is saying. Now, is the requirement satisfied? No, we wanted to unify batch also. So this data is streaming from here. How do we bring batch? This was a batch. But what if someone gives you a batch to be sent into the top layer here? What's happening here? So let us say I have a batch of data, right? So I have a batch of data. All right. So I have a batch of data. Let's say 5 million JSON records. Okay. They say that you feed it into this pipeline. Where should I upload? I will just read from here, static read, right? Because it is not a stream. I am reading a batch, read. I will read from here and write it as a batch here in this folder. So write it as a batch, not stream. Write it as a batch in this bronze folder so that it goes in the pipeline ahead. I will directly upload it into the bronze folder, but obviously in the delta format. When I upload it, I will use dot format delta, and that unifies batch processing model. So this is the batch model of processing, batch, and this on the top is a stream that's happening. So unify streaming and batch in such a way that everything is fault tolerant, a systematic refinement procedure, bronze, silver, gold, and use Delta Lake engine on top of data lakes so that whatever data you maintain is fault tolerant and you are able to recover from faults in case they happen. The Delta Lake architecture, a reference architecture, right? So this is called as the reference Delta Lake architecture.
So guys, if you liked our video, then do give us a thumbs up. But if you really want to learn more about the particular topic we discussed, then we have something really special for you. We have our free class on Microsoft Azure Data Engineer certification, that is DP203, along with some question and answers, where we'll be discussing about why is everyone working on data, importance of some Azure services you should learn, and many more things. So for that, all you have to do is just log on to K21Academy.com/Azure DE02, and after that you'll be seeing a screen like this. Just click on book your free seat now. Select your event date whenever you're available. Reserve your spot by adding your name, your email address, and your phone number, and you'll be getting all the updates via mail. You'll be seeing this kind of window on extreme right, so you can save this link, add to your calendars, and I'll see you in the free class. Till then, keep hustling and take care.